Today we're going to learn two more tools that can be used to solve a system of equations. We're going to learn how to solve with a graph and how to solve with a table. These are just additional tools that we can add to our systems of equations toolbox. When we have to solve by graphing, the first step is to actually have graphed your equation on an XY coordinate plane. When we're looking at a graph, we need to think about what's an x value that produces identical y's when you plug it in to both equations. Basically, the result should be the same y value from both equations. You're looking for an xy pair that exists in both functions, that exists on both lines. So if we look at this graph, the only point that exists on both lines is this point right here. That is the point of intersection. Point of intersection. That is the only point that exists on both lines. Because there's only one point of intersection, I'm only going to have one solution. And my solution is 6, 1, the ordered pair for that point. Let's take a look at the second graph. Here we have 2 points of intersection. Since I have 2 points of intersection, I'm going to have 2 solutions. I need to write the ordered pair for each point. Remember, the x value is always written first. And here you have your 2 solutions. In summary, when you're trying to solve by graphing, you need to look for your points of intersection. Let's take a look at how to solve with a table. Make sure you've generated a table of values for both equations. Here's a table for equation 1, and here's a table for equation 2. What we're looking for is, again, an xy pair that exists in both equations, so it would show up on both tables. So let's take a look. Is 1 my x value? No, it's not, because this has a y value of 6, and this has a y value of -1/2, so that's not my answer. Let's test another one. Is 3 my answer? Nope, because this has a y value of 4, while it produces a y value of -1/2 in the other equation. So that's not my answer. Let's try 6. Is 6 my answer? I think so, because 6 produces a y value of 1 in this table, and 6 also produces a y value of 1 in the other table. So it's one x value that produces the same y in both equations. So my answer is 6, 1. Remember, when I'm solving with a table, I'm looking for a point that shows up in both tables.